Hello everyone, in this video I'm going to present the dashboard of spiral visualization. The dashboard of spiral visualization consists of two main components. The first one is the sidebar and the other one is the main window where spiral visualization is shown. So the sidebar consists of the following options. The first one is ranking the nodes. A user can rank the nodes belonging to a community based on different measures. For example, degree centrality, closeness centrality, betweenness centrality, and eigencentrality. Similarly, a user can change the color coding. The color coding can be based on the centrality measures as well as on the density measure. Now we can even choose to hide and show the edges as and when required. Finally, the user can reset the visualization after performing various operations. Now coming to the main window, in the main window we can see that first of all there's a legend that explains that what all colors are used in this visualization. Red color represents high value, yellow color represents medium value, and green color represents low value. Then black color represents outliers. For example, let us consider an example of social networks. In social networks, they generally follow power law for degree distribution. The power law states that in a social network there will be very few nodes that will have very high degree, and there will be a large number of nodes that will have low degree. So in that case, those nodes that have high degree, that can be considered as outliers, and that can be shown using the black color. Then comes intra-community edge and inter-community edges. So intra-community edges are, for example, if a node is connected to another node present in the same community, that is called as intra-community edge. And on the other hand, if a node is connected to another node in another community, that is called as inter-community edge. So intra-community edges are shown by a cyan color and inter-community edges are shown by blue color. Now there's some additional information that is being shown, that is the number of nodes present in the data set. Currently this visualization shows 7,624 nodes and edges. There are 27,806 edges. So the ranking used is degree. By default we use degree centrality because degree is the most popularly known centrality measure. Then color coding is based on density. So this is the default options, and user can definitely change using the sidebar options. Now let us analyze the spiral visualization. So if a user sees this visualization, he can quickly see the number of communities present in this visualization, because a spiral very clearly it shows the community. We can easily count the number of communities present. For example, in this visualization we can see that 1 2 3 4 5 6 7 8 9 10. There are 10 communities. Then comes the size of the communities. So in this visualization we can easily comprehend the size of the communities. These are some of the communities that are smaller in size, and these two communities are larger in size. Then comes the density of the communities. As we can see in this visualization, most of the communities are low density, and there are very few communities, only I think this community, that has a high density of connections. Then we have a link between nodes. So the link between nodes can be either intra-community or inter-community. So if we hover on a node, we can see, for example, we can see the cyan color that shows us inter-community edges, and the gray color here shows that community number 9 is connected to these all communities. So if we analyze other, we can even see some blue colored links that show us the inter-community edges. Then community connections. So this visualization, it clearly shows us the community to community connections. The thickness of the edges, it shows us the number of interconnection between two communities. For example, we can see that this community is community number 2 and this is community number 3. So when we hover on this link, the information appears in here. It shows that community 2 and community 3 shares 130 links. Similarly, we can analyze other link. For example, community 2 and community 0. This is community number 0. They share 77 links. The thicker the edge, more are the number of interconnection between two communities. Then the most important feature of this visualization is that it facilitates comprehension of node centrality. The nodes that will be on the periphery, they will have low degree. For example, if we analyze this particular community, if we hover on a node here, we can see that degree that node 7599 has degree 1, and on the other hand, if we hover on a central node, we can see that its degree is 16. Then a distribution of the degrees, distribution of centralities. If we rank a node based on a particular option, for example, if we are ranking based on degree, and we also color based on degree, so we can easily comprehend the distribution of different centrality values. The green color shows that all these nodes have low degree, the degree ranging between somewhere between 1 to 4, yeah. And then yellow color represents somewhere between 5 to 10 or maybe 11, and then red color represents somewhere between 12 to like 17. So we can see the degree distribution, and the black color nodes, they are those nodes that have really high degrees. So the similar thing can be done with the other centrality measure. We can see the distribution of closeness. We also have to color code based on closeness, so we can see the distribution of closeness centrality measure. So yeah, that's it. Through this visualization, we can comprehend a lot of characteristics of communities as well as the nodes. So this proves to be a useful visualization. Thank you.